So assalamu alaikum everyone. So in the previous session, as we discussed database and we started our discussion on SQL as well. So I'll just go over some concepts again so that to sort of refresh you the things that we did, and we'll start the SQL. So how will I teach SQL is initially I'll introduce the concepts, introduce the concepts, and after introducing the concepts then we'll do the practical. So in this session we'll be in this, so most of the things will be theory based. So इसमें हम लोग theory पढ़ेंगे, then when we have at least some understanding of theory, then we can have some hands on and we can code the things. Okay, so as we saw that this SQL stands for structured query language. So the basic concept was that this is the language by help of which we interact with the databases. This was the basic concept of this. By interaction I mean we can create, then maybe we can update, or do some other manipulations or something like that. So these are the interactions that we'll do with the databases, and that we'll do by using this SQL, structured query language. So if you see, there is something called as database schema, or we call that database schema. So in the previous session I started talking about this IMDb dataset. IMDb dataset. So what was it? Basically this dataset is a huge collection of movies, I think from 1800s till 2008 I guess. So in this database they have the data of the movies that have been made in this area, and then the actors that have played the role in movies and what the rating of movies, and there is a humongous amount of data that has been collected since this 1800s to I think it is 1888 or something like that to 2008. So now we have to create a database out of this. We have to arrange the data. As we saw that we'll be working with relational data. So we'll be working with relational data. So for that we have to create this relational database first. So basically what we have to do is we have to create a schema, database schema. Okay, by schema I mean, for example, if we are creating a relation, so relation by default, I assume that you know relation basically is a table. So in this table we'll be having many attributes, and then we'll be having many rows, that's tuples, the data records. So we have to organize this data in such a way that the retrieval of the data, updation and things become easy. So I'll just show you one schema that I have here. So if you see that we have made different tables for this data. So this is the schema of IMDb. So this is IMDb schema. So we had a huge data and we had to put in the database so that we can update, we can retrieve the data. So for that we have created a schema first. So what's the meaning of schema is how we have arranged, how we have organized this data into our different tables, into our different relations. Let's start with this movies data. So we have a table over here. So let me change the color so it's clearly visible. So if you see, we have one table movie. This is the movie table in which we had three attributes: ID, title and production year. By ID I mean there's a unique ID for this movie, then the movie has a title. For example, if there is a movie Shawshank Redemption, so it is a name, that is the title of the movie. Then the second thing is we had the production year, the year in which the movie was produced. So we made one table out of this. If you see in here, so there is a mark over here, this says that this ID acts as a primary key to this movie table. Okay, then we have other tables, for example movies genre. So genre means that for example if movie is comedy, is it action movie or something like that, we have a movie ID here, then we have a genre ID or something like that. So if you see this schema, so we have distributed the whole of our data into different tables. So here we have 1 2 3 4 5 6 7 8 9, some 11 12 tables. So if you see this is the information about actors. So here we have, so it has that actor table contains ID, name, gender, birth country, birth year, death year, age group, death cause, height group and some things like that. So this is how we arrange this data. So if you see that we have also made the primary key for each the table, we have a primary key. So if you see in here, So this ID is the primary key for this table movie. So if you have this language, this ID is in the this primary key to the language. So most of the things that IDs are primary keys. So we have some foreign keys as well if you see. So if you remember the concept of foreign keys, so these arrows basically mean they are the foreign keys. Okay, so people are messaging me. So if you have any problem in,
उसमें लिंक तो बोल रहा था ना जनरेटर भी तो बोला
can you just mute? So what I'm saying is that when creating a schema, for example, consider yourself as a database engineer, so who is creating these databases, so a data admin. So what you have to do is when you look at the data and you have to find how many tables to create basically. So let's suppose we have the college data. Now I just showed you the IMDb movie data and we created many tables and we created these foreign keys, primary keys for all the tables. So in the similar fashion, in the real world, what we have is sometimes, let's suppose you are running a college. So in the college there is a huge data of students, and there is a data of students, then there is a data of teachers, then there is a data of courses which are offered. Okay, so let's suppose we have this huge data, we have a lot of data, and we want to create a database out of this. The first thing is we have to create a schema like this. We have to see how many tables should we create, which attribute should be the primary key of the tables and stuff like that, and you have to create this schema, and these diagrams are called ER diagrams. Okay, ER means entity relationship diagrams. So I'll just write the full form here. So this means entity relationship diagrams. This is like if you want to construct a house, so for that you first give a blueprint of that thing. So this ER diagram is sort of a blueprint. How will you create the database? Okay, so this is how we create these schemas. So we'll be sort of doing all the analysis on this IMDb dataset. So that's why I told you in the real world how are these schemas made and how are the things made. Now we'll go into concepts of SQL. So what are the things that SQL support and what are the operations that are there in SQL? I hope the things are clear till now. Is it clear? Okay, we'll initially start with some rules of SQL when you are defining SQL. So what are the rules when you write the statement? So I'll just write SQL rules. So here I'll write rules of SQL statements, of writing SQL statements. Rules of writing SQL statements. Okay, so what's the first rule is that whenever you want to end a statement, so as you know that in programming language we write statements, so when you want to end a statement you will end that by using a semicolon. So for example, if you write a statement, let's suppose select, for example, you don't know what select means, so let's suppose that this is a keyword select from, let's suppose table name is students, select from students, and you are writing some statement like this, and at the end you are putting a semicolon. That means this is the termination of the statement. It acts like a full stop. So it says to the parser that, or to the compiler of SQL, that you have to stop the statement over. If you do not put this semicolon, sometimes what happens is that the query won't be able to run because it expects a semicolon at the end, so that it knows that this is the end of the statement, and till this I have to read it. So this is what, and the thing, second thing, this is the first rule. The first rule is that you have to end your statement with a semicolon. Second thing is, these statements, they can be split. The statements can be splitted across lines. So what I mean by that is, for example, you can write a multi-line statement. It's not that you just can write one line statement. You can write multi-line statements, but at the end you can just put a semicolon, so that you tell the parser, you tell the compiler, you tell the execution engine basically, this is the statement I want to execute. These statements can be multi-line and you can just split it, but you cannot split the keywords. As I told you that keywords have specific meanings in SQL, or in or the, for that matter, that in every programming language. Let's suppose a keyword here is select. So select is a keyword, so you cannot separate it. You cannot write SEL then put a space then write ECT, something like this. You cannot do this. You have to write it without spaces. Okay, and then there are other rules as well. You have to separate clauses with the with the space and stuff like that. So these are the rules that I want you to remember, because when we will be coding, at least you should know this. They should end with a statement, and you can write these statements. You at least should write these statements. You can write this statement in the multi-line, and at the end you have to put the semicolon. So there are other rules as well, which we will discuss while doing the real-time coding. So, but I want you to keep that in mind. So there are rules to write the statements, as we had these rules to write keywords and stuff like that. Is it clear till now? One of you have to speak because I cannot see the meeting screen.
Yes, sir. Yes, sir.
Okay. So now I told you how to make these schemas as well. So now let us see what are the data types that are supported by SQL. So data types in SQL. Because the fundamental thing is, I told you that fundamental thing in here is you have to mention, for example, if you have a table in here, because you have to fill table with the data. Okay, you have to fill this table with the data. So we must know what is the data type that these things support. As usual, like we can have numeric data and we can have the textual data, but in the numeric data type, if you see this numeric data type, so what are the things that SQL supports? The first thing that SQL supports is what's called as big int. So big int ranges from minus 263 to 262. 263 minus 1. So this is the range. So if you want to have an integer, you want to, for example, suppose you want to specify an integer which is in this range, so you can just define a big int. Because if you have a variable, let's suppose you have a variable over here, age, so you can say age and then type is big int. This is the type over here. So we'll see what's the syntax that's involved, but just keep in mind that big int is one of the numeric data types that you can define. Then we have int. Okay, so int has the range from minus 231 to 230. Okay, so this is the range for int. So we have big int, then we have int, then we have something called a small int. Small int is another data type. So this is basically under the numeric data types. So it ranges from minus 215 to 214. So if you want to have a number which is in this range, so you can define it as small int. Then we have something called as tiny int. So you might ask a question, why are there so many types of data available in here? Because in databases, we know that we deal with lots of data. So it really matters if you can even save, let's suppose, 1 byte of the data. So if you let's suppose say 1 byte of the data in each of the column, then if you have thousands of things, then you can easily save gigabytes of data. That's why SQL has these number of data types. So you have to carefully choose what type of data, because you have to look at the space, how much space will it take. So if you know, for example, age is a number which will be just in the range, let's suppose, from some 0 to 100 or 0 to 150. So you have to accordingly choose the data type, because you don't want to allocate an integer or allocate a variable the data which it won't never use, so as to save the space. So is it clear why there are so many data types of just integers defined in the SQL?
Sir.
Yes. So this tiny int, so it ranges from 0 to 27. Okay. Then we have bits. So bits, they store 0 and 1. They store 0 or 1. Then we have something called as decimal as well. Okay. Decimal, or numeric we call them. So I have written it. So numeric, so range depends on the precision, how much precision you want. So it depends on how much precision you want. So I hope that I have also discussed what is the precision, meaning of precision. So I hope you recall that precision. Then we have a variable called as money or monetary money, or is sometimes called as small money. So these variables, they store the monetary values. For example, if you have value something like let's suppose 10,000 rupees or $1 billion or some things like that. So you can store that in these money or small money variables. This is the data type. So monetary values, I can say. So monetary values are stored. So you don't have to remember them, but just keep in mind that there is a huge types of data that's available in SQL, so as to say the space, because as the database designer, you have to care about the space. So that's why you must have these things handy. So you must know that there is a lot of data types which I can use. Then we have what is called as approximate numeric data types. So these were exact number. Then we have approximate. We have approximate numeric data types. So in approximate, this basically is a subset of the other data. They have a range. In this we have float, and we have real, and then we have double. We have real as well. So these are the range here is, so there is a range, particular range, minus 1.79 into 10 to the power some 308 or something. So it is written basically, simply we can write it like this: e 308. This means like you have to raise it to power to 1.79 e to the power 308. So there is a specific range for real numbers as well. So this is called as approximate numeric data type. So this is what we have, the data types that are available in numeric data types in SQL. Then we have string types as well. So there we have another data type called as string data types. String data types. So as you know that string is a bunch of characters. So in that we have the first thing is character. So if you just want to sometimes define a character, let's take an example for the category of gender. You can write male or slash female. So there is only one character required. So you can just say it is a character type. So character is just, you can have one character, and it basically uses, and the maximum length of characters can be basically 8000, but sometimes in order to save space you can use this. So then we have varchar. So what is the character means? You can write it like this: character and one. I just want to define one character. Sometimes you can write I want to define multiple characters. Character, for example, 200. So the limit will be 200 only. So you cannot store more than this. So varchar is basically variable character. So what it does is, if the character this is fixed, so here this is fixed. So this varchar is dynamic. So it is not fixed. So if you call this like varchar, you can variably length. So if you sort of fix this character as 200, and sometimes maybe you will use only 100. You are writing a name, for example, let's suppose you defined it as 200, so it will allocate 200 space. But sometimes you may use only 10. For example, I'll write somebody's name John, so it only used 4 characters. For example, for some other name I'll write Zubair or something like this. So other space is wasted. So for that, if you think that your data it is varying a lot, so you can use this varchar, and most of the times you will be using this varchar. Then you have varchar max as well. So for that you have like this is a non-unicode data. So this is again varchar, and then you will put a max in here. So this is in the data type. So and then we have a textual text. Then we have text. Okay. So here the maximum length of characters, if I have written it somewhere, so it is 21274834647 characters can be there. So you don't need to memorize these numbers. You just need to know that there are the string data types which I can use. Okay. Then there are other things as nchar, and varchar, and things like that. So in nutshell, I would like to say, and I would again there are some other data types like date. So for example, you want to store date slash time or something, date time. So there are separate data types for date and time. So the first thing is date. So if you just define some variable as date, it will store date. So there is another variable time, it will store time. There is another thing called as timestamp. So date stores the date. For example, it will store some year, maybe some month, year, or day. So time stores the timestamp in hours. Then we have some minutes and seconds. So this timestamp, it is a mix of date plus time. So you might have seen if you make a transaction in the bank. So there, when you make a transaction, they'll tell you the time and the date that you made the transaction on. So they're basically using this timestamp data type. So there are other data types as well, like XML data types and some other special data types. So there's XML data type. There are something called as spatial data types. These data types are used to demonstrate geometry of objects. Geometry, for example, if you want to have a square or something, because you have coordinates, and for that we are using these special data types. In nutshell, I would like to say that there is a huge variety of data types that SQL provides, and in order to save space, you must know that these things exist. And when you are designing a database, when you are creating a table in the database, so when you are giving that variable type to these databases, you should be very careful, because sometimes these databases are having billions of records. So for that, if you just save one byte in a record, so you are basically saving maybe tens and hundreds of GBs at least. So is the concept of data types clear? Is it clear?
Yes, sir.
Nice. Then, as we saw, there are components in SQL. So we'll look at the components of SQL again, and we'll see different commands that are in SQL. So if you remember how I talked about four components of SQL. Components of SQL. So today we'll look at what are the commands in those components. Okay, so what's the first component that I talked about? Maybe I'll create a table like this. So if somebody remembers, can you say what are the components? Okay.
For data definition language.
Okay, let's write with data definition language, DDL. So in this you
DML,
then what is D?
DML, data
Data
manipulation
manipulation
language,
language. Then what is the other one?
data control language,
Data control language, and other one?
transaction control language, TCL,
Transaction control language. Okay,
control language.
transaction control language, so TCL. So what is this data definition language? Is where we create. So I'll tell you what are the commands that are available in this. So what are the commands by which we can do? The first obvious command should be, there should be a create command by which I can create things. Okay, then there should be a drop command, so by which I can delete something or create something. Then there should be alter command. These are the commands that are available in DDL. So one more command is truncate. The basic necessity of this component is that you are creating, altering, dropping, or doing something on the data. So here you are not doing any manipulation. So these are the commands that are available in this component. So whenever you are creating a table, you want to create a database, you basically will be using these four commands. So you must know how to create, you must know how to drop. Basically means delete. So but the command's name is drop, this actually means deleting something. Okay, alter means to change something. If you have a variable, if you have an attribute name and you want to change it to something. And truncate means if you want to again delete, but there's a difference between drop and truncate. By drop I mean you are deleting whole the table. Truncate just deletes the data in the table but keeps the table in there. So this is, let's suppose this is some delete plus plus, so it deletes whole the table. So when you will apply truncate on something, it will just delete the data from the table, but it will keep the table there. Then we have data manipulation language. In this we have to insert things. So when we manipulate the data, so you have created a table now. So you will use this create function to create tables and things like that. So when you have created the table, now you want to insert the data into that table. So we have a function insert. These are not functions, basically these are just the commands, declarative statements I'll call, because I have told you that this is a declarative language, it's a non-procedural language. So they are just declaration statements. So we have a statement insert, then we have update. Okay, insert means if you are inserting something. Updation means then if you want to update, you have a data in that and you want to update it, update, and you want to add another row or column. Then we have delete. Okay, delete is also a command. Then we have call, and you have call. Okay, just let me write it separately. Just know that these things exist and we'll see what are the functionalities, how do they work. Then we have explain call. Then we have explain call, and then we have lock. Okay, so these are the commands, these are the statements, or these are the things that are available in data manipulation language. Then we have data control language. Basically control means you are giving control to somebody, authorizations to some other people. So there are only two things that you can do. You can either grant, okay, or revoke. So grant means you are giving some access to some user or giving some access to some other people. So revoke means you are taking back the access. Okay, so these are the only two things that you can do in this data control language. Then we have transaction control. So in there we have commit. Okay, then we have commit, we have rollback, and then we have save point. So commit means when a transaction is done, so you'll commit the transaction. if you have some problems in the transaction, you will roll back it. And sometimes what you will do, you will create those save points, like till this point I have to roll back it. So you know that till a certain point the transaction was okay, after that I don't know, so you will save the transaction till that point. So when you will roll back, you will roll it back till the save point. Okay. And some people also categorize the select command as data query command. So basically I'll write the select command over here. So if you have to select, it's also sort of manipulation, but some ways on some websites or some books you will see it under different category of data query language, DQL. So they call it when you query something, because you have to select things. This is only one command. Like preferably we should be putting it under data manipulation language, because selection is also some sort of manipulation. Or if you do not agree that selection is a manipulation, like people usually put it under data query language. Or the SQL, these are the commands in SQL. Okay, components in SQL and commands. Because why do we call it a command, one and a function? Because it's a declarative language, we just declare something. So that's the reason we're calling them commands. So is the commands, now we'll go into the in-depth details of these commands, how do they work and things like that. So is this clear?
Yes, sir.
Okay.
Yes, sir.
Let me first show you, okay, how to create a database first. Okay. So in the next session, when you will come to the next session, when we will be doing some real coding, so you must know that why to execute these commands. As we saw that Python needs an interpreter. In the similar way, you should download MySQL server. So just write that MySQL, download it from Google. Just search it on Google and you will download it from the website. So this is the installation process that you have to do. Installation. I'm using Linux machine, so I have a different installation procedure. So when you will be going on this MySQL's official website, so there you will see the steps mentioned by which you can download. Okay, so here I'll show that I have installed the MySQL. I don't need to again do the installation, but I hope that it will be easy for you guys to find some videos on YouTube or find some blogs by help of which you can install this MySQL server on which you can run these SQL commands. Okay. So let me now go to, is my terminal visible? Yes. So now I have installed SQL. So I'll skip that process of installation, because there are a hell lot of videos available and there are a lot of blogs written by the people how can you install these SQL. So this is your homework, this SQL installation. How do you install SQL? So when you are done with installation, and you will put the password in the SQL. So in Linux, what I write is I'll write MySQL -u means user, root means the privileged user, and .p means I am having the password. So I'll press enter over here. So it will say me enter the password. So I'll write my password, whatever it is. So now it said welcome. So I was able to get into the MySQL. If you see now over here, so over here if you see it, here it is MySQL is mentioned on here. Now I am in that MySQL. Now I can run the MySQL commands. So after the installation, this is the first thing that we will be doing. So we'll be running this command MySQL -u root -p. So by the way, help of this, you will get access to this MySQL, and you can run the commands. So now I want to create a database. The first thing is, if I go back to the window, so first thing is I'll have to create a database. Okay, this database is some sort of thing, so where I'll keep my data. So I'll create a database. So within the database, then I can create tables. So I can create tables or relations. Okay, in those relations, what I can do is I can add, insert, or do things like that. So how to do that is, the first thing is how I can create my own databases. So there is a command called as create. So you can write it in the caps or you can write it in the small case. So it doesn't really matter, but usually there is a norm that when you are writing an SQL query, you write these keywords into capital letters. You'll be seeing like this: create, and then you'll write database. Then you will
So
name the
screen is not visible.
Okay. So you'll write this create. Create is a keyword. Then you will write the database, and then you will write the name of the database. For let's suppose we are learning machine learning and deep learning, so we'll create it. So if I just run it, now you saw that it is still expecting me to write something, because I did not end it with a semicolon. So I had to put a semicolon to tell it was the end of the query. So when I write this, so it says query okay, one row affected. So now if I want to see was my database created, I can write show, okay, and I can write databases. and again I have to put a semicolon. So you can see that there are other databases that I created, but this MLDL is at the top. So is it visible? The first thing is we created a database, we named it MLDL. So we named it MLDL. This is the database that we created. Now we have to select this database and then we can create these tables and things into this database. So what I can do is I'll go back, and if this is visible, what I can use, I can write use function and then I can say MLDL. This means now I'll select this database. So here it says that database changed. Okay. So is it clear? So now I have selected the database. So I've selected basically this database. Now I can create these tables and whatever I want to do with the database. And I can create a table. Let me just give you an example of how to create a table, and I'll just create a table, because now you know that I am inside this database because I'm using the database this MLDL. So here I can now write a command. So here I wrote a command, create table of employees, and then I have written employee ID is int primary. So if it is visible over here, so you can clearly see employee ID is the first variable and it is of type int. So I told it's a primary key. Okay, so here I mentioned that it's a primary key. So then again I have written first name is of type varchar. So this is of type varchar. Then last name again is of varchar. Then email ID. Then hire date is of type date. Then salary is of type decimal. Okay. Then is active is of type boolean. So that's why I wanted to introduce the data type. So now I have created a table. Now I can write a command show tables. Show tables will tell me how many tables are there. So I have just created one table. I'll just write show tables. So now I have to terminate the command. If you see, it says that in the MLDL, the tables, there is tables in MLDL is employee. There is only one table. Okay. If I want to now describe the table, so if I want to see what is in there in table, I can write a command that's called describe. Okay. So I'll just write a command describe. Describe what is the table name? It is employees. So if I write it and I'll terminate it, you can see this is the field. Field is of type employees, then it is of type integer. So is this visible to you, this field and things like this? Is it visible? Yes. So here what we have done is I have just told you how to create a database. Then inside a database, now we are creating these tables. Okay. So after creating the tables, you can have functions. So till now what we have seen is, I'll go back to the screen where I'll explain the things. So here what I have done is, the first thing is we have first checked how to create a database. How to create a database. I'll write DB for the database. Okay, this is the first step. So why I'm using terminal? Because there are other things. For example, Windows they provide user interfaces, graphical user interfaces to, they have these buttons to create the databases. But I'll strongly urge, being computer science students, you should use these command line things because it gives more control. You should not use these graphical user interface things where you have these interfaces, you'll click on something. You should manually know how to do things. Okay. The first thing is we learned how to create database. So what was the command? So command was create. Then I wrote database. Then I wrote the name of database, name. Whatever the name of database was, I wrote that. So this basically created a database. So if I created the table, so similar thing was there. I don't want to bore you with the syntax because that this hands-on experience we'll be doing on a real data set. But here I want to introduce you to the concepts. So what are the concepts in databases? The first step is that you have to create a database. And then afterwards, if you want to see how many databases are in your system, so you can write a command to write, you can show databases. So you say this is a plural S, here there is no S. So when you create database, so you can just write create database. So but when you want to show, you can write show database. But now you have to use the database in which you will be creating the tables, these relations where you will be creating those. So for that, what you have done is we have used a command use. Then we have given the name of database, name. So whatever the name was. Okay. So this is how to use. Then we also create a table and we also run a command describe. So describe basically told me the things of the table, what are the fields in the table, and what are the types of these, and it showed me a different information. So till here we ran these 4 commands. So is this clear? Is these four are these four commands clear?
Yes, sir.
Okay. So my point here is not to teach you right now how to do handstand, but I want you to have a holistic view. We are creating something. For that, the first step is create a database. So when you are done with that, you have to select the database. When you're selecting that, now you can add tables and data into that, and you can do the other operations as well. Now we'll move on to the different things that there are in SQL. So I hope that this thing is at least clear. So how to create these things. Okay. So I have also covered this. Okay. My today's goal is to only introduce you the concepts, not to tell you how to code these things. Today we'll be only having the sort of theoretical knowledge of what are the things that are available in SQL. Then in the next session we'll be doing hands-on, and we'll be working on this IMDb dataset. So we'll be working on this dataset. So why am I doing it? Because I have seen people learning more when they know things first and then they do it. And I have seen multiple people that are teaching on YouTube, or there are different tutorials online. They do not introduce the concepts. They'll first directly try to code, and they'll say, let's create a table, create this and that, and it sometimes becomes a mess in our head, and we're not able to figure out what are the things. So the best thing is first know the concepts well, then come on the hands-on part, because the most important thing is you must know what are these things doing. So that's what I'm doing. The first phase is I'm trying to convey to you what are the things that SQL provides you, and by the help of which you can do things. So now you know the basic terminologies of table and relations, these tuples, degree, cardinality, and things like that. And now I will introduce you the concepts that are available in SQL. Okay. As this also is a language, so we also should treat it as a language, as I said you. So there are comments as well. So there are comments in SQL as well. Can somebody tell me what are comments for? So why do we comment our code?
Make the code very readable, much readable and understandable, as well as to the non-coders, non-programmers.
Not to the non-coders, basically to the coders. You have to write documentation for the people who will be coding. So your code is not basically read by the people who do not know how to code. You have to write the code because you will be working with a team, and sometimes they won't understand what you have done. So in order to do that, you must do comments, so as to facilitate the people who will be writing your code and understanding that. So here we have single line comments. Single line comments. So what I told you, that if you know a programming language, the concepts get repeated. The only thing that gets changed is the syntax. How many of you remember this line? I told this in the first session of Python. So how many of you remember? Just raise your hands. Okay. So again, this is a language. The concepts will be the same, just syntax will be different. So single line comment, how do we do a single line comment in SQL is, you will just put these two hyphens, I'll say. So for example, if you have to if you write a query, we call it query. We don't call it a code or something. We call it query. When you write a query by using this SQL, if you want to comment it, what you will write? For example, you will say like this. This is a single line comment. Then you will start writing your query. For example, you have a data, you have a table which is named as customers, and you want to select something from the table. You will then write a command select star, select everything from customers. I don't want to focus on this syntax. We'll be doing this syntax when we'll be going to the coding's hands-on. But here, see that how we have defined a single line comment. Let's say this is a statement, SQL statement, and here it is a single line comment. Single line comment. Okay. So then we have multiple line comments as well, or we can say multi-line comments. Again, the same concept that we did in Python. In the Python, we use the triple quotes and things like that. Here, what we do is we'll use the C syntax, that is backslash star, and then we'll write multi-line comments. Okay, then we'll close it like this. Is it clear? So this is the multi-line comment. Then we can write whatever we want. We can write the example statements or example SQL queries. Let's say SQL queries. Okay. On top of that, we have one more comment that we can do in SQL, that is called as inline comment. Okay, so we have an inline comment. If I have written that inline comment, so what is inline comment? For example, you sometimes want to write a comment inside the line. So you are saying, let's suppose you are writing a query, you are writing an SQL, you are writing an SQL statement. So within that statement, sometimes you want to put a comment in there. So you can do the similar thing. So let's suppose I'll do like this. So I have a statement select. Okay, so select, and then I can put a comment over here. If I write select from, select, this star means select everything from, let's suppose I write table name like this, table name, and I'll close it again. So I can again start the query from here. Select table name, let's write customers here. So as you saw that I embedded this comment within the SQL query. This is an SQL query or SQL statement, but here you have a comment. It's written similar like multi-line comment, but I have embedded within the statement. So I embedded it within the statement. So this is called as inline comment. So you can do these inline comments, you can do these multi-line comments, you can do these single line comments as well. Is the concepts of comments clear? I hope that is clear because we
Yes,
have
sir.
seen it multiple times by now. Okay, now we'll go in depth of the concept called as transactions. Transactions. Okay, as you have seen that we saw something called as transaction control language. So in the previous session, I just briefly described what these transactions are. Today we'll be going in detail what are these transactions. So what basically, first we'll write what is a transaction. So if I tell you the definition of transaction, so any logical unit of work, okay, it may be containing, it may have multiple tasks. For example, it's a set of multiple tasks. So it begins with a specific operation and concludes with a specific operation, and when all these operations are successfully completed, we call that a transaction happened. So if I have to write a definition, I'll say a transaction is a logical unit of work within the database. Okay, so this may contain multiple tasks. This logical unit of work, it may contain multiple tasks. Okay, let me give you an example, like first abstract example, then we'll go to the real world example. So what I call a transaction is, let's suppose you are eating a food. I'll call it a transaction because it contains multiple tasks. So eating a food, first you will wash your hands, and then maybe you will sit down. Okay, then maybe you will bring your plates and things like that, and you will eat, and you will again wash your hands at the end. Okay, so there's a series of tasks if you see. Okay, so eating is a unit of work, let's call eating is a work. So there are different tasks involved in eating. So when it begins with a task and it ends with another task. So we call a transaction is complete, or transaction has, we have done a transaction when all of these units are successfully executed. So we call that this transaction, this happened successfully. So in the example of eating, so if somebody interrupted you in between because he did not allow you to eat the food completely, so you said that the transaction has not completed. So by completion I mean that all the units, all the tasks that unit of work had, they were completed. We call that transaction. We call that transaction was complete or transaction was successful. Simply I'll say transaction is a logical unit within the database, and it may contain multiple tasks, and it starts with a specific operation and concluded. We'll say that transaction concluded when these all tasks are successfully completed. Okay, is it clear? Is the concept transaction clear? I gave you the
Yes, sir.
example of, I think, Rian and Mahvish. So I'll again do the similar thing. I'll just break that down. So we'll give an example of a real world thing: bank transaction. Bank transaction. So here we had two people. The first guy was Rian, and let's suppose this is Rian's bank. Then the second person was Mahvish. Suppose this is Mavish's bank. So we have two people who are doing a transaction. So what are the steps involved? So this is a unit of work. So the unit of work is transferring money. Transferring money from Rian to Mavish. So this is our unit of work. So this is what I mean by a transaction. This is our transaction. So let's now see what are the steps involved in it. Okay. So the first step, I'll write the steps. Okay, steps involved in this. So the first, let me write the steps. The first thing is we must read the account balance of Rian, because Rian is transferring the money. So in order to see if the balance is there so that he can transfer the money to Mavish, so we must read the balance the Rian. That's the first thing. Okay, let's suppose we want to transfer some 50 rupees, and here Rian has 1000 rupees. Let's say Mavish has in a bank account some 2000 rupees. Okay, so we want to transfer these 50 rupees from Rian to Mavish. The first step involved is that we have to read the balance of Rian. Okay, the second step is that we have to subtract 50 rupees from Rian's account. This is the second step. The third step is we have to update Rian's balance. This is the third step involved in this. And then again, next step is read Mavish's account balance. Then increment it, basically add. Let's suppose 50 rupees to Mavish's account. Okay. Then at the end we have to write updated balances. Update Mavish's balance. So this whole step is this is one transaction. Okay. So is the concept of transactions clear? So you saw that there are multiple steps involved in the transaction, and even within these steps there are, for example, in this reading and updation there are different steps involved. So we can also like go boil down that, but briefly speaking, if you see that these are the major steps that are involved. So these are the major steps that are involved in a bank transaction. So this is what we call a transaction. We'll say that a transaction is successful only if all of these steps from here to here are completed. Otherwise, we'll say the transaction was not completed. A transaction should follow what are called asset properties. So we'll see what these asset properties are. So I'll say these transactions should follow asset properties. Okay, they should follow these asset properties. So what is this asset? The first thing is atomicity. So what is this atomicity? So by atomicity I mean this should happen, the transaction should happen, or it should not happen at all. So we cannot say that there is a partial transaction. It should either happen altogether, or not at all. That's the meaning of atomicity. The first thing is that transaction should happen completely. It should either complete or it should not happen at all. So we should either complete all of these steps. All of these steps should be completed. Otherwise, no step should be executed. So that's the meaning of atomicity. Whenever you are dealing with a transaction, whenever you are creating a table, whenever, for example, you are doing anything, you are doing some change, you are transferring bank account, you are even updating something in the tables. The thing is, it should either update or it should not update. So that's called the atomicity. It should happen or it should not happen at all. So it should happen completely or it should not happen at all. That is the meaning of atomicity. The second thing is consistency. So A means acid, as in from the acid property. A means atomicity, then C is consistency. What is the meaning of consistency? So when we are doing this transaction, this database should change from one valid state to another valid state. So both of these states should be valid. So when we had this initial state, it should be valid. When we had this final state, it should also be valid. So in this bank transaction, so what is the consistency? If the bank balance initially was 1000, plus 2000, that is 3000. So initial balance was 100,000 plus 2000, that was 3000. So after it was a valid state. So after the transaction was over, this should again be 3000. So if there is an inconsistency, discrepancy in the balance, so we'll call this transaction is not consistent. Okay, so it should transaction should maintain data consistency. So when we move something in the database, it should move from one valid state to another valid state, so that these constraints, the things that we enforce on the database, it should get maintained. So there should do not be any inconsistency. Then we'll say another property is called isolation. A means, where is this asset property? A means atomicity, C means consistency, then I means isolation. Okay, so what is the meaning of isolation? So by isolation I mean that there will be hundreds and thousands of transactions happening concurrently. So thousands of hundreds transactions will happen concurrently. So what should happen is, so when all the transactions happen, they should not affect each other. So they should not affect each other. It should look like that all these transactions are happening in isolation. So one does not have an effect over other. So for example, if I am doing multitasking, let's suppose I am teaching you guys something at the similar time I may be eating something. So one task should not affect my other task. If it's affecting the other task, it's not in isolation. So by isolation I mean if the things are running concurrently, if the things are running at the same time simultaneously. So one transaction should have no effect to the other transaction. So sometimes what happens is, let me give you an example. Let's suppose at the similar time somebody is sending some money to my bank account. At the same time I'm receiving this. Let's suppose I'm receiving some amount and I'm sending the amount at the same time. So on the similar account, two things are happening simultaneously. So for example, if these processes had an impact over each other, so maybe there will be inconsistency. It will look that maybe this receiving of money and sending of money, they had an effect over each other, so we'll not get the desired results. So what we want is, we should receive the things in isolation and we should send the things in isolation. It's not that we'll isolate the things, we'll wait for the things. Let's suppose, let me receive the money first, then I'll send you the money. So we can send and receive at the same time, concurrently we can do that. But there should be an impact like this, that as if we are doing the both things in isolation, as if we are doing them separately. So that's the meaning of isolation. So if I write the definition is a transaction should occur independently and isolated from each other, ensuring that concurrent transactions do not interfere with each other. Okay, so I'll write concurrent transactions should not interfere with each other. And so they should seem as if they were isolated. So whenever transactions happen, so it should look like that the transactions are happening in isolation. So the other thing, last thing in the asset property is that duration. Okay, so there is this duration, or durability we call it. Durability. So what's the meaning of durability is that, so one transaction, if it is committed and it made some change to the database, so if we did some transaction, so by transaction I mean that we'll make some changes to the database. So we'll make some changes. These changes should remain persistent. So even if the system failed, but still these changes should be there. So if the system fails even, so the changes should be persistent. So what I mean by durability in the real world example, for example, if you learn something, no matter where you go now, no matter, God forbid, if you met an accident, these things should still be persistent. It should be with you there. So that's the meaning of durability. If you are doing a transaction and you are making some change to the database, so database still if there is a failure or something like that in database, so still these changes should be persistent. They should not have any impact over these changes that were done. Is it clear?
Yes, sir.
Okay. So I think it was a question asked in GATE somewhere. So they told what are the, so what should these transactions follow. So which property should they follow. So they had given these asset properties as one of the options. So when you will be writing these things, for example, in databases, so there you have to keep in head that these things, when I'm creating a transaction, when I'm creating database like that, so they must follow these properties. Otherwise, my database is not consistent, and it will have some failures, some problems, and which will be reflected when you do these transactions. So there are three things what we read in this transaction. So there are three. If you see this, so if you see this TCL, that is transaction control language. So in there we have written three things: commit, rollback, and save point. So let's see what this commit, rollback, and save point does. So today I am teaching you the theory. Again, ingrain this in mind. We are not doing any hands-on, but if you know these concepts well, it will be really easy for me to code these things. I'll just code and I'll say I'm selecting a thing, I'm doing this thing. That time I won't have to explain you the theory behind that. So you'll be easily knowing. So what are the things? Because you will be laying your foundations, and you'll be understanding the concepts behind those things. So the next day I'll be just writing select this from that table, do this from this table. So that time it will be really easy for you to understand. Just keep this in mind. So if it is boring and you can just stop me there, sir, can you give us a break of 4 minutes or something? So I'll stop there, but do not lose the focus, because all the SQL is based on this theory. So theory will look like a cakewalk. If you understand this thing, it will hardly take you another hour or so to learn the SQL then. So but only thing you have to is focus here. You have to focus as much as possible in here. Am I clear with this?
Yes, sir.
Okay. So the first thing that we have is commit. Okay. So this is the command which we'll be using, and we'll do commits. So it will have its definite syntax and things like that. We're not worried about syntax at this point. So here we're worried about the thing that commit does. So what's the meaning of commit? So meaning of commit is that changes are finalized. Changes are finalized. So when you are sure that, when you are happy with your transaction, you believe that whole of these steps, whole of the process that I showed you is completed. So you'll commit that process. By commit I mean that you are finalizing the change. Whatever the transaction you made, you call it successful. So you will call commit at that point of time. You'll run commit statement at that point of time. You'll run commit command. So you'll say that the change has been successfully finalized, and transaction has been successful. So what is the effect of this? So I'll write commit. So what is the effect of this? So effect of this is that these changes become now finalized. Changes are made final. Changed are made permanent. Permanent. So when it is done, so when you think that we have made the transaction as this is the finalized transaction, so you want to do some permanent change, so you will call this commit. So what it does, it will do permanent changes. When will you do it? You will do it when you think that the transaction is finalized. Okay, so the effect of this commit is that changes are permanent. So they are visible to other transactions as well. So even if the system fails now, still you will be able to see this value. In our example, that we see that if Rian sends the money 50 rupees to Mavish, now whatever will be done after the transaction, Mavish's balance will be seen as 2050 rupees. Okay, because we have done commit. So all other transactions will be seeing the updated balance. Even if the system is failed now, it doesn't matter. So because you have committed the change. So this is what I call the meaning. So meaning is, so changes are finalized, and what is the effect? So effect is that changes are made permanent. Whatever change you have done, so when you think that they are finalized, you will make the permanent change. Then we have a concept of rollback. Okay, in the previous session I briefly discussed them. Today I am sort of going into detail, so that we are just left with the syntax and why to use them. Okay, so here again let me explain the two-step process that I am taking. I am explaining the concepts first. Okay, this is the first part that we'll be doing today. So then next part is how to apply those concepts. Apply those concepts to the real world problems. So what is the problem that we'll be solving? We'll be doing some analysis, something on the IMDb dataset. Please have a look at this dataset as well. So have a look at this IMDb dataset so that coding becomes easy. So I just want to take maybe one or maybe 1.5 session other to cover this SQL, and I think I have covered in detail the databases. So if you sort of go with this background to any, maybe if you are urging for having a software development role, there you'll be using these databases. So this much of background will be enough for you. So I don't think you need more background. Even if you are going for gate exam or some exams like that, and maybe you just have to read some other things like transaction control management, things like that, and normalizations. But more the basics we have covered in here. So what is the rollback? Let's see what is the meaning of the rollback first. So let's see what is the meaning. What is the meaning of rollback, and then we'll see what is the effect that rollback has. The meaning of rollback is that it reverses or discards the change made within the transaction. So whenever a transaction encounters an error or fails at some point, so what it does is it reverses the effect. So the meaning is that it will reverse or it discards the change. Discards the change. So why does it discard? Because we think that the transaction failed or was interrupted. It was interrupted or the transaction failed in between. So what will you do is will reverse or discard the change. So what will be the effect of this? So effect will be that it will revert back all the change. So it will revert database to some valid configuration, to some valid state, let's suppose. So it will undo the change. When it will reverse and discard the change, what will happen is all the changes that were done in the database, it will revert them back, undo them back to get the database into some valid state again. So that state that it was initially when that transaction started. So that is the meaning of this. So that's the effect of this. The meaning is that we are reversing or discarding the change. So what is the effect? That it will take the database from an let's say non-valid state because the transaction was interrupted to the state where it was valid. So this is the other command that we will be using in the transactions. Then we have something called as save point. Save point. Let's again see the same thing. What is the meaning and what is the effect? So why am I teaching in this organized way? So that it is ingrained in your brain. Okay, save point, the meaning is this and it has this effect. What save, the meaning of it is it marks something. So marking of something, let me write it with yellow. So marking to a specific point, marking at a specific point. So as you saw that we had a bunch of tasks in a transaction. So sometimes what we do is, for example, let's suppose we have 1, 2, 3, 4, 5 and 6. These are tasks and we'll call transaction complete if it started from here and ended here. But we know that there is a high chance of failure over this or at this point. So but we know that most of the times transaction goes till here, then it fails at here. So what we can do is we can save the change to the step 3 because we know after this there is a chance of failure. So we'll create a save point in here. So how many of you have used Windows and they create restore points? So when you think that your machine is working really fine, so what you do is you will create a restore point. So whenever your machine is not performing well in the future, you will revert back the machine to that restore point. So how many of you have done that with the Windows if you are a Windows user? Has anybody done it?
No, sir.
So there is the option in the Windows, for example, if you feel that Windows is really working better, so you can create a restore point at that time. So when your machine starts slowing down and things like that, you can revert back your machine to that point and you call it a save point or you call it a restore point in here. So in there you call it a restore point, in here you call it a save point. So you have different subtasks in a transaction. So when you think that till this point my transaction is usually successful, so you can create a save point in there. Then maybe if there is a failure, you can get back to that till that point. So what is the effect of this? It basically gives us a chance to enable partial rollbacks. Enable partial rollbacks. Why partial rollbacks? Because we are not now starting the things from the scratch again. We are not starting from the step 1. So what we are doing is we are starting maybe from some intermediate step till the point we have saved this thing and we believe that the transaction was okay till that step. For example, in this case we are having the transactions till this step, and that's why I'm saying that it enables partial rollbacks. Okay, so it will undo half the change. For example, if some changes were done and transaction failed over here, so it will undo change till here. So it will undo change here. That's why I'm calling it a partial rollback. It's not a full rollback. Full rollback means that it will again start from scratch. It will undo all the change from step last to the step 1. But here we are doing some partial rollback till the point where we have saved these transactions. Is the concept of this commit, rollback and save point clear? Is it clear?
Yes, sir.
Nice. So let me talk about views now. So we have, let's assume we have created database and there are multiple tables in databases. So there is a concept of view. We have also covered this concept in NumPy arrays, if PVU people were there. So what is a view basically? Let's suppose we have a table 1. So here I assume that we have created a database in which these tables are there. So we have table 2. Table 2. So this is table 1. This is table 2. Let's suppose the attributes in here are 1, 2, 3, 4 and 5. And the attributes here are A, B, C, D and E. Sometimes there is there is a thing what you want to do is, you sometimes want to query something. You want to get out of maybe these 2 columns and maybe these 3 columns together. So for that, what you do is you will create a virtual table. What you will create, it will not be a real table. It will be a virtual table. So virtual table basically is called a view. So you don't actually create a real table. So we'll just write a query. There's a query where we'll use views and it has separate syntax. I don't want to go into syntax. So here I'm just explain the concepts. So we will sort of create a table which has this. You have a, let's call it a view table. View table. So what will be there is, there will be this 1, 2, A, B and C. And the data correspond to these things. Whatever the data was in here. So you know that this table was not there. This was not the table we created. These were the real tables. These were the real relations. So these are the real relations that we created when we were creating the database. So we're creating these tables. So but sometimes you want to get data and you want to query the data from this and this together. But you want some partial columns of this, some partial columns of this. You don't want to query both the tables together. So what you do is you will create a temporary table. We call a virtual table. It's not a real table and you will use these views. Okay. So they are basically the virtual tables. The purpose is basically you want to customize the data. So if I write it in a well organized fashion, so what is the meaning of it again? So they mean we are creating a virtual table. Creating a virtual table. So creating a virtual table because this table was not into existence, but we created it, and it is derived from real tables, or real relations. Okay, I'm using these words interchangeably. These relations, tables, these tuples, row or record, and some things like that. Okay, so what is the purpose of this? So this is the definition. Maybe we're creating a virtual table. It does not exist in reality, but we'll create a view out of this. The purpose is they allow, let's call users, for example we are the user, database manager or something, to combine subsets of different tables. And when we combine these, now we have this virtual table. Now we can treat it we can treat this view table like these 2 tables, table 1 and table 2, and we can get data out of this. Okay, is this clear? Is the concept of views clear?
Yes, sir.
Okay, so one more
Yes, sir.
thing that views does is, so they basically give the role to the people. So authorization, the grant access. So sometimes what you want is you do not want to share the whole things with the people. For example, you are a database admin. So you're a database administration. So you have different types of employees. You have grade 1, grade 2, grade 3 employees, things like that. So what you want to do is, because you have this data, so no, you want to make a table of data separate for other thing. You want to just show these 2 and 3 columns plus this A column to let's suppose grade 2 employees. For grade 1 you want to show let's suppose 1, 4 and 5. So you can create views for this. So one more advantage is that these views, they restrict the user, they restrict the access, and you can control the access. So by creating those views, you can sort of restrict the access to the users, and you can define, okay, these set of users, or this group of users should have access to this group of users should have access to this. So if you even sometimes see how we make database, for example, we are creating a website for this. So there for the people who will be registered in our, so we will restrict the content. So maybe we'll keep some content free. Let's suppose we have a list of content in there. So we'll have video 1, video 2, video 3, and something assignment 1, assignment 2, assignment 3. So what we'll do is, so the people who are more serious and who are our registered students, will maybe give them access to all this content. Okay, so for the people maybe who are not our final students, but they still want to see what are the concepts that are being developed upon, so we'll just give the access to maybe video 1 and maybe assignment 1 or something like assignment 3, something like this, and we'll give partial access to this. So there you can use these, you can construct these views. Okay, so I am talking about the software engineer perspective. If you are creating a website or you're creating a software, and even in the softwares, if you see these things, so you want to give the subset of data to some people, and you want to give some other subset of data, extra subset of data to some other people. So there is where these views become really important, the views in databases. Okay, I don't again want to delve into the syntax details that we'll see in the next session. So how to create a syntax. So there is something create view and view name. So I don't want to delve into that. So what are the advantages? Simplified data access. So we are using data abstraction. So let me write the advantage again. So I'll just summarize the advantage. So advantage, the first thing is simplified access. Simplified access. So why is it simplified access? Because otherwise we have to merge these two tables again, write the data, insert data. So it's better if we have data in some other tables. Why to create this data again? Just make a simplified view, make a view, and it you can access it simply. So this is simplified view. The second thing is data abstraction and security. Data abstraction and security. So because you are making it more secure by giving little access to the people that you want, and by giving a subset of data to some people, by giving some other subset of data to some other people. So you are doing that. You are keeping the security and you are abstracting out the data. And one more thing I can write is that consistency and reusability. So you are reusing the same data again and again. So you are not creating new data. So you are reusing data. What does the meaning of consistency? So if some changes are happening, so we had this table 1 and we had the table 2. Table 2. So in the view, this was 1, 2, A, B, C, D, E, something like this. This was 1, 2, 3, 4, 5. So what in the view we had 1, 2, A, B, and C. So this was our new table, our view table. So whatever change will happen on this table 1, or whatever change will happen on this table 2, automatically this view will have those changes. So that's what the meaning of consistency. So for example, if you created the separate table, so if you made change in this table, you have to make changes in the view table as well. But when you create a view, because this is not an actual table, this is the view table, a virtual table. So whatever changes you will make in this T1 and T2, automatically the change will be visible in this view table. So that's why I have written the data consistency. It provides the data consistency. It provides reusability because you reuse the same data. It provides security because here you can control the access. It provides data abstraction because you abstract out these things. And the simplified access is that you don't create new table. You just use the whatever you had, and you'll basically have the simplified access, not creating the table and having the burden of creating this other table from the same data. Is this clear?
Yes, sir.
Okay. Then we have some other commands. For example, there is a command of role, ROLE role. So what it does is, again, I'm not going into the syntax. I'm just teaching you the concepts. In the next session, just revise these concepts really well, because that time we'll be coding this. I won't be again explaining what is the role, what is the meaning of this, maybe comment, rollback. I'll just write these things and you will have to figure out what it's doing. Okay. So now we have this role. So role is basically if you want to have access control. Exploit is access control. So you want to define a certain role, you want to give access to certain people for certain files, and you want to restrict the access to other people. You can define rules for this. Let's suppose you are creating a website, or you are maybe creating something. So in that you have 100 users, and you are categorizing these users into different roles. Maybe somebody is just a normal user. Maybe somebody is a database administrator, so he should have access to all the things. Database admin. So by using this role command, you can restrict or you can give access to the people. Okay, so there you will create roles, like you will create roles to people. Even if some people among you have created the websites, so there you might have seen master dashboard, some other things like that. If some people are viewing, if you are even using Facebook, so there if you use your personal account, so there are a lot of details that are available to you only. but for the people who are visiting maybe your profile, they have limited access to that, and that whole thing is done by using this role. So you are defining the roles basically. View it as a user, view it as a visitor, view it as yourself or something like that. So all the things is basically done by this role. Okay. Hmm. So we had transactions, we had these views. So let's move to the other topic of indices. So you also saw creating roles, so you can create different roles. So we'll now see the concept of these sequences. Okay, the concept of sequences. What in the sequences, what sequences basically mean? So SQL, if you want to generate numerical numbers, let's suppose from 0 to 100, so you want to fill that in, let's suppose you have to create numbers in a sequence from 0 1 2 till 100, and you have to fill that into some table as an attribute. So what SQL provides is that, as you know, there is a declarative language. It does not have those for loops and stuff like that. So many people have questioned, why do we have these sequences again? Because I told you that this is not a general purpose language. So here we do not have access to these for loops. You cannot use for, you cannot use a while loop to create these things. So the best thing is, what you can do is, from the SQL it gives you what are called sequences. So sequence, so they'll generate these values. The first thing is they'll generate these values, the automatic sequential value generation. So they'll generate these values automatically, and they will be gapless. So there will be no gaps in between, no gaps. So for example, it will start with 0 1 2, it'll increment it accordingly. And then why is it used? Because for example, it is used for the efficiency purposes. So if you want to do the things like that, otherwise you have to write your own for loop, maybe using Python, and generate a list and then maybe append that list again. So it is better for the efficiency purposes. Efficiency, you can make use of these sequences. Okay. So there is, again, we'll see the syntax of how to create a sequence and how to do these things. So there is some initial value, why to start it, maybe initial value, and then we have a final value, why to stop it. So keep in mind that SQL is not a generic language. So in order to create these things, we have one thing: either we can create a list of things by using a normal programming like Python or C or C++, then append these things. Otherwise, SQL itself provides this creating of these sequences. You can create these sequences. Okay. So why do we do it? Because of the efficiency. So we don't need some other language like that. Then we have a concept called indexing. Okay, we have and the concept of indexing. So what is this indexing? So now you have these files. So you have a lot of tables. So I told you have T1 maybe till T100, and they are somehow related to each other. Okay, so now you have to access these things. So what you do is you do what is called as indexing. So indexing helps in faster access, faster retrieval, so what, will keep indices over here. So how many of you know about hashing?
जी सर.
So if you know about hashing, it's a searching technique. Basically it performs the searching really fast. But here what indexing is that, so indexing will create some indices onto these tables. So it will use some trees called as B and B plus trees. So in order to make these the data access and this really faster, if you want to perform, if you want to query and you want the results to be with very high speed, what internally databases do is they'll use this indexing. Okay. So they improve the speed of data retrieval. Okay, they, because they provide the paths. And if you want to delve into the more details of how indexing is implemented, you must know how these B and B plus trees works, and then you will be able to know, okay, how the indexing works so fast, and why do we get, for example, out of this I want to get a specific row out of this table, so I'll query the database, and by using the indexing it will be really fast. Let's suppose there are 10 billion rows, 10 billion tables, as from the table we have to create that. If you have this indexing, it will be really faster. So indexing is used for faster retrieval of data. So they are implemented by using B and B plus trees. So if somebody wants to know how indexing works, just search a topic, and there is a good I think NPTEL video series on this databases topic, and they go into in depth of these details. Okay, and you can maybe read that if you want to go develop into deeper things. So the only point is here, the purpose here is that the data should be retrieved really fast, and it gives us the efficiency. in that way. And we can create different indices. For example, if we have the rows, and we can create indices by our own hand. And you might have seen that in pandas as well. We create indices, but indices there were for different purposes, and we use the index for plotting and things like that. Here the purpose of indices is faster retrieval. So there are different types of indices. So types of, I'll just mention the types. So the first thing is single column indices. Single column, maybe index we'll call it. Look, single column indexes means like they are created on a single column of the table. Okay, then we have composite indexes. Composite indexes. Okay, so composed indexes are that, for example, if we want to have index for multiple columns. So in this table, if I want to create an index, because let's suppose this column is A1 and I frequently access it, so I'll create a separate index for this because it has made, let's suppose, 10 billion records in it. So in order to fast access that, we'll create index for this column. So that will be called as single column index. So sometimes we collectively want, let's suppose we have another column here, B12 or something like that, and we want to collectively have faster retrieval of this A1 and B12. So for that we'll use composite indexing. Okay, or then we have other things like as unique index and things like that. So that we will see when we'll be just keep this in mind. This indexes is there for the fast retrieval, and there are types called as single column index and composed column index that we'll be creating. Okay, is it clear?
Yes, sir.
Okay, so this was the basics of SQL. Now we'll move to some other things, and I hope that you know the background, you have that background, you still remember the concept of keys and stuff like that, because I won't be explaining the concept of keys again. Okay, so here we'll see that now there are something called as constraints on these values. Constraints. Okay, so what are these constraints? So let's suppose now we have a table. Okay, so we have a table, we have a relation, let's call it T1. So there are different columns, different attributes. Okay, so these are the attribute list, and here we have the data. Sometimes we know that if suppose there is a column age, we know that age value, it cannot be null. It cannot be, basically it cannot be negative. Okay, it cannot be not a number. So if somebody is there, if somebody's name is there, let's suppose here we have an attribute name. If somebody has a name in here, so he must has corresponding age. So maybe he's just a newborn, maybe we'll start the age from 0, but it cannot be it should not have null values, it should not have negative values. So what I mean by constraints is that, so there are specific set of things that are not allowed in a particular attribute, in some attributes. Okay, so they are called constraints. So in simple, constraint basically they are rules which must be followed, which must be followed. So for example, when you do something and somebody puts a constraint on you, so you, let's suppose you are saying that I'll go to the school, and the constraint is that I'll come back before 4. So this is the constraint. And sometimes what I am teaching you machine learning and deep learning, but the constraint is I have to complete that thing within 3 months or something like that. So constraints basically are you are doing something, but you are putting some additional constraints over yourself. Similar thing with the attributes. So the first constraint I'll be discussing is unique constraint. Let's discuss what are the types of these constraints. The first constraint is unique constraint. Okay, so what is this unique constraint? So for example, if we want a column to have all the unique values, we'll say that we'll put a constraint onto that column, that column must have unique values. Let's suppose here, if we are making Aadhaar numbers, so Aadhaar numbers are unique because each other person should have a different Aadhaar number. So if we are making a database of Aadhaar cards, so what we'll do is we'll put a constraint on this attribute that this must be unique. So unique basically means there should be no repeating values. There should be no duplicate values. Because when you are creating a table, suppose you create a table, you told a database to create a table. So then within the attributes you can call, for example, this Aadhaar, and you will write unique. Basically you will tell the database that we are not allowed to use the duplicate values in this Aadhaar. So that is one constraint we can put. Unique constraint is a constraint by which we can tell that an attribute cannot take duplicate values. Okay. Then there is another constraint called as not null. Okay. Not null basically means, as I showed you in this age. So if some person is there, if somebody's name is there, so he must has an age. Or maybe like this, for example, name should not be null. Okay, so there should be a constraint, not null. Not null means you cannot have an empty value. Empty value means not a number value, or you cannot put null values. But sometimes you may put null values. For example, for some variables you may put null values. Let's suppose we have residence. So for some people we may not know what is the residence of that people. We may put null values for them. And for some people, for example, in some other cases, when you are creating some database, in that somebody is not having a degree. Let's suppose while creating Aadhaar database, somebody is uneducated, so he does not possess a degree, so he has no basic education. So here you will put a null value because he does not have that degree. So not a null means necessarily there should not be any value in that column, any value in that attribute where there should be null value. So this null value is not permitted. Okay. Then we have this primary key constraint. Primary key constraint. So what is that? If you want to make something primary key, so it must be unique and it should not have null values and not null. Do you agree with this? So what is the primary key? That's why I told you that you must know what is the primary key. So who will explain what is a primary key? In brief, maybe in 1 minute. Who will explain it?
Sir, it is a key which has like unique value and used to like identify tuples in a table.
Okay, so then what's the difference between a candidate key and primary key?
Sir, primary key is used to identify table like all like it is
Not the
the
table,
main.
basically
Primary key
row,
is
a
selected
particular
out
row.
of candidate keys. Sir, primary key is selected out of candidate keys.
Right.
Candidate keys can be many keys, but primary key is selected one of them, sir.
So then do you agree that the values should be unique and they should have not null values? Because the assumption here is that primary keys are able to identify these records uniquely. So if we have a table, in that table we have a record, and in order to identify this record uniquely, we are keeping a key. So those records must not be duplicated. So it should be unique and it should not have not null. It should have not null values. It should not basically be empty or null values. So that's how we make primary key. So if you are making an attribute primary key, so you must ensure that it has unique values and it has not null values. So that's why we call it a primary key. So this is another constraint. So when you write something as a primary key, so definitely it will have unique values and it will have not null values. Okay. So then we have what is called as foreign key constraint. So foreign key constraint. So I told you that foreign key basically means when one table's primary key is referring to something other. So we have a key and it is referring to some other table's primary key, stuff like that. So we call it a foreign key. So that foreign key basically it uniquely identifies each row of another table. So if we have a table in here, if we have another table, and maybe this value, this attribute, let's call it f1. This is able to uniquely identify each of the rows in this table. That's what I mean by foreign key. So f1 is basically uniquely identifying tuple or uniquely identifying records of some other table. So we call it a foreign key. Okay, is it clear? So when you create a foreign key, so this is a constraint. So you cannot, for example, there is something called as cascade on delete, cascade update. So what that means is if you have a foreign key, let's suppose you delete this foreign key. Now sort of we lost access to this. So you should not do that. So what you say is on updation you should maybe cascade these changes. We'll look into that. What's the meaning of cascading on delete and update on delete and things like that. So foreign key basically this again is a constraint. If you are making something foreign, if you are making a foreign key, so there is a constraint over that. So then we have a check constraint, and the constraint is check constraint. So what is the meaning of check constraint is if you want some value to be greater than something. Let's suppose I am creating a Aadhaar database for the people who are elder than 5, who are elder, or maybe their age should be greater than 5 years. So we are using this check. So while defining that attribute, while defining that variable in the table, what we are doing is we'll use this check command, or we'll use this check thing to define that age should not get values less than 5 or less than equal to 5. The age must be greater than 5. So for that purpose you can use this check constraint. Is the check constraint clear? Then we have at the end default constraint. What's the meaning of default constraint is that if for example salary, Let's suppose we are having a table of employees and we define salaries. So if one employee is not given salary, for example, he has just joined us, maybe his salary is yet not defined because he's maybe doing some internship or something like that in the company. So what we'll put is we'll put some default value over there. Let's suppose 25,000 is the default value. So if you put a default value for a variable, so if you do not enter any value while you're inserting the data, so by default it will take that value. So that is the meaning of the default constraint. So we saw different constraints. What we saw is we saw unique constraint, we saw not null constraint, we saw primary key constraint, foreign key constraint, check constraint, and default constraint. Are these constraints clear?
Yes, sir.
Yes, sir.
Okay. So we'll be actually going into the details of these constraints. Well, we'll be making the table and then we'll be adding the data into these tables. So we'll be going into all the details of these tables. So how much time is left? How we still have some time left. So I think till this point what we have covered is, so what how to create a table. So basically everything that I have covered till now is how to create database. So what are the things that you can do with the attributes. Now we'll be going on to that manipulation wala part, while we'll be, for example, doing some operations on the data. We'll be manipulating data. So till this point, if you see, we're just defining the things. We're defining what these constraints mean, how to create a table, and things like that. So for that, if you want to manipulate anything, for that a language should have operations. Okay, a language should have operations. So SQL also provides us with many operations. So if you want to do something on, for example, you want to, let's suppose, add some things to all these rows. Let's suppose the salary increment was 10% to all these employees. Now in this salary attribute, you want to make this 20. You want to make whatever the salary was there plus salary multiplied by 25%. You want to give the 25 increment, and you have to make these changes over here. So for that we must have operations, because SQL is a language, so we must have operations in order to do this manipulation of the data. Is this clear? Why do we need these operations in SQL?
Yes, sir.
The need is that because we have to manipulate data and we have to update the tables and update the schema accordingly. So for that we must have the operations. In the similar way, again, there are operations which we have earlier studied, arithmetic operators. Okay, then we have comparison operators, then we have logical operators. I don't need to go over the details because we have seen them in depth. So what are these arithmetic operators, what are these logical operators, what are these comparison operators. Okay, so we'll be using them. Just keep in mind that these are the operations that will be there. Okay, so there are some special operators that I want to mention. There are some special operators that SQL provides. Okay, so what are these operators? These operators are on top of these. For example, you want to manipulate arithmetic is there, comparison there, logical is there. We'll see them in action when we'll be using them with some queries. But these special operators, just keep them in mind. There are some operations. For them, there is an operation any. So you just write any, a and y. So what is the meaning of this? So any value that basically, for example, if you have a list, so any and all. Let me explain both of these together. So there are two operations, any and all. So this any and all, if you see it mathematically, because I told you all this relational algebra is based on the set theory, or maybe I will call it set relation in functions. So any basically means there exists. If you have seen in math, there exists. Okay, and all basically means for all. How many of you have heard these terms at least? There exists and for all. Have you heard these things in mathematics? There exists and for all. So what I'm saying is, let me go to the set theory to explain these things. Let's have a set 1, 2, 3, 4, 5. So there exists means if I say if there is a condition and if at least one of the element follows that condition, I'll say that that the condition may be true. For example, what I'm saying is, there exists is written like this, for all is written like this. Going into the mathematics, a little bit of mathematics here. So there exists means the condition should be true if at least one element satisfies the condition. For all means everything should follow the condition. So what I'm saying is there exists, let's suppose I'll give a condition, number should be odd. So if at least one number is following that, I'll say this condition is satisfied. So here we have 3 is odd, 1 is odd, and 5 is odd. So this condition is basically true here if I'm saying there exists. So I'm saying for all, number is odd. Let's suppose number is odd. number is odd. Okay, so here this for all condition basically is violated because all the elements here are not odd. So their exists requires at least at least one element should satisfy the thing. So for all basically means everything should satisfy, every element should follow. That's why I'm saying for all the elements should follow whatever I'm saying. There exists means at least these should at least one should be there. At least mean if other elements are following, well and good. If not, if they are not following, then it's still okay. But this there exists means one element among all the elements should at least follow the condition. For all means everything should follow the condition. So now we'll go to this any and all. So what we do is if you want to do a comparison, and if any of the values, for example, you are using a query and you compare that with a list of values, maybe you compare that with rows of values. You are saying if at least one row, any of the row follows that condition, return that row. For example, you are saying you have a different value in those rows, and you are saying if one value at least is positive, return that row. Let me give a concrete example so that you understand it better. So let's suppose we have a table, and in that we have different rows. So what you are saying is because these values, let's suppose these are numeric values. These rows are filled with numeric values, and it has different attributes. So what I'm saying is sometimes I'm saying is return me those values, any for which if any of the value is positive. For the rows, if any of the value is positive, return me those rows. So it will return the rows in which at least one element is positive, in which at least one of these values is positive. That's the meaning of any. So return me those, if I'm using this any to compare. So what I'm telling it to give me the rows for which at least one element is positive. So if that condition is satisfied, it will return me those rows. If none of the condition is satisfied, then it will stop it. For example, here if I write numbers like 2, 4, 6, 8, I'm saying there exists an even number. So there exists an odd number. There exists an odd number. Then it becomes false because every element is not following that condition. So if otherwise at least one element was following that condition, I'll say that I'll return that row. Here what I'm saying is, so I am looking for positive values in the rows. So if I found at least one positive value, so I'll return that row. Otherwise, if all the values are negative, then I'll not return that row. That's the meaning of any. If at least one of the attributes or one of the comparisons is true, then we'll return that rows. What is the meaning of all? So I'm saying return the rows if all the values are positive. If here even single value is negative, that row won't be given to me. That row won't be selected. So all means the condition should be satisfied for all the values that I'm comparing against. So any means for at least one of these values, the condition should be satisfied. Is this clear? Is the concept of any and all clear?
Yes, sir.
Because these things will be frequently using them in the queries. Okay. Then we have some other things like between. So we have things like between. So between basically what it does is it says the SQL, for example, if it wants to test a range, it says from this range, from and to. It gives us a range of values. So from 15 to let's say 35. So we can compare some things like if you want to return the people who have age between 15 and 35. So there is an operation between. So there is an operation in, which checks for the values. If we have a list of values, let's suppose Sunday, let's suppose Monday, and we have something, and we'll say Sunday in list. So if we call this in, it will check if it exists there, if the list has that element. So there is that exists. Exists is also there. So exists is that checks for existence of subquery, and there is again some, there is unique. So we'll explain them more when we'll be using them. Just keep in mind that we have some special operators in SQL as well. Okay. So on top of the operators that we have these arithmetic operators, comparison operators, logical operators. In SQL we have some special operators that we'll be using. Is this clear?
Yes, sir.
Yes, sir.
Okay. So how much time is left? I think the time is over now. So it has been, I think, more than 1 hour 30 minutes. So we'll stop here. But whatever we have studied, these were the basics of the SQL. So whatever we'll be teaching from here will be more or less hands-on code. So we'll be just putting our hands on the code and we'll writing the code for all of these, and the rest of the operations that are there. For example, we'll see the aliases, we'll see what clauses mean, and then we'll see what is a wire clause, using clause, and all of these things I'll explain with the code, because now you have at least a solid background for understanding of how to create these databases and then how to manipulate these things. So you have at least a broader view of the things. So if you are given a data and somebody tells you create a database for that, so this is actually the backend development if you see it. So if you know, this is called the backend. I'll stop recording over here, and maybe I'll also take your questions if you have some.